Okay, folks, welcome to the Seattle Robotics Society meeting for July. Let's see, we're going to do our normal format here. Let me share a screen. Okay. Okay, video is not being provided by Microsoft Teams. We have to get Steve to update that slide. For those of you on Microsoft Teams, we don't see you or hear you, and we're not there. So we are recording the meetings. Please mute your microphone unless you have something to share. Anything you put in chat will actually be recorded as well, so that'll come up, and then Steve will get that on the website. We're going to follow a typical meeting agenda, and yeah, everybody pretty much knows that one. Let's see. Oh, the other one is after the meeting, if anybody wants to hang around, I've got to leave right about 12 o'clock today, but I will transfer ownership of the meeting to whoever happens to be left around, and the last person out just close the meeting, and that'll close it for everyone. So don't think because the meeting ends you have to, go home. Wait, you're already home. Okay, Zoom chat, you can ask questions, make comments, share links. That is captured, and I'm actually watching it at the moment. Steve is out today, so I think he's traveling, so I'm going to host the meeting if you guys haven't picked up on that already. Steve is planned to be back next month, at which point I think I'm gone. So let's see. First Washington is looking at selecting a new location in the fall, probably about August. It's going to be somewhere between Kent and Tacoma from what we know. We'll start our in-person meetings, assuming everything's mellow with COVID about that time. We will continue to broadcast on the Skype meeting or on the Zoom meetings as well. So the club at this point has a Zoom account, and we're free to kind of use it for everything we need. So we'll adopt a hybrid model. We're not quite sure what that's going to look like. We will also need volunteers, both remote and on site, to help run the video gear. Let's see. Okay, I just did this one. If you want to help out with running meetings or running video gear, get in contact with Steve at seattleroboticsociety@gmail.com. Let's see, kids robotics classes. So Steve is doing a weekly robotics class with kids at the church in Burien. They're actually using the Elegoo smart robot car kits. Steve did a little bit of a talk on that prior as well. Actually, he did a full talk on that at our Robothon Exhibition, which was July 10th. If you missed that, the video is now posted on the YouTube channel. So just hop onto YouTube, and that's where we're putting all these videos. Let's see, the website's getting a major update. They need suggestions for videos, tutorials, kits, whatever you can do to help out. Just let Seattle Robotics, or let Steve know at the prior email. Once we get that site up and running, links to the videos and chats and everything else will be posted up there. So today our presenter will start at probably, let's say 10:45 to 11, depending on how things go, is Zheng Lei. I'm saying that wrong, but he also goes by Real Thunder. So we'll have him talk about FreeCAD. Let's see. Anybody knows a presenter, feel free to get in touch with Steve on that. Reach out and let them know. Do not actually schedule them yet. Steve will do the scheduling, but hook Steve up with them and they'll get that going. So Steve's always looking for presenters. He's actually in pretty good shape for next year. So that's actually good. Normally getting presenters is a lot of work. Let's see. The coming presentations are posted on the SRS homepage. Please note the February 2022 meeting is going to be a one-time special event. It's going to be from 3 to 5 Pacific Daylight Time in the afternoon. So our presenter is coming in from Japan, obviously on a video link, and we will move the meeting time to make it reasonable so it's not like the middle of his night or something. So just a note, February 2022 will be a special meeting time. Here's the presenters we've got so far. Let's see, so if you look, wow, it looks like he's actually booked out until April of 2022. So that's actually pretty darn good. Oops. Okay, if we do have a speaker drop out or we don't have a speaker, we'll do some of the open discussion forums. And there's a topic. This is pretty much what we talked about before. Steve or anybody else will host these, and it'll just be an open discussion for the meeting. Let's see. So we've got I mentioned this before, on July 10th, we had a Robothon Exhibition. This was a series, for those who couldn't join or didn't join, this is a series of essentially, they were 20 to 25-minute presentations. Very short, we had 6 of them on all kinds of different topics. We will be doing this again. We actually, we got 6 in this time. We actually had about 10 people sign up on the initial round. So we'll be doing more of these in the future. Our next planned event will be for sometime in October. We keep the meeting to about, or we keep the event to about 2 to 3 hours, depending on session length. So it's a little longer than a regular meeting, but it's not too bad. And then we take regular breaks during the session. So the next one will be in October. Stay tuned, and we'll get that organized. We're doing these in lieu of the actual Robothon competition this year. So that is still on hold. We will probably, seeing how things play out, we'll probably start that up again in 2022. But with COVID and the various restrictions and the uncertainty of what can you do and what can't you do, we've gone to these virtual events for the moment. So we'll keep hosting those until we can do a full-on Robothon. And even once we start doing a full-on Robothon, I think we're going to keep these virtual events as well. They're turning out to be pretty popular. If you're actually looking for more virtual events, there's a Robo Columbus event, which is sponsored by the Dallas Personal Robotics Group. That will be on August 21st. So the contest starts at 10:30. We've got 1 member so far from our group participating in it. That's Donna. And I'll be assisting Donna with that. So again, this is a totally online event. It's a Robo Magellan, but they've adapted the rules and the way the contest is run so we can do it online. So there'll be people from Dallas there. As I mentioned, there'll be people from our group there. Probably people from other groups. So this is one of the neat things about the hybrid stuff, is you can bring people from all over the world together and do these things where it was completely impossible or impractical to do that before, because people would have to travel and so forth. If you're interested in purchasing a workshop robot kit, we have both the propeller-based and the Uno-based kits available. Steve has some, I have some. The Uno-based are 125 bucks. And just let us know if you want one, either Steve or myself, and we can get together with you. We can do check, cash, card, whichever. Propeller-based is $135. Again, check, cash, card, whatever. Let's see, virtual robot. Yep, so I mentioned this earlier, the workshop. So after the meeting today, if there's anyone who wants to hang around, I'll transfer ownership of the meeting to that person, and you can feel free to transfer it on. Basically, we don't shut the Zoom session down until the last person's ready to go. The workshops are not recorded, so we'll stop the recording right after the presentation. Okay, around the room, who has something they'd like to share? And go ahead and just open your mic or raise your hand.
This is Greg. I can share some progress.
Okay, got Greg. Who else?
Jim here.
Jim, okay. We got 2. Anybody else? Okay, let me release my screen here and... Okay, Greg, go for it. And you got plenty of time, so...
Okay, thank you. Just a second, let me just reorientate this, or maybe a better viewing experience. Okay, so I've been working on Gidget's ARM, has been really the focus of my attention. I'm now on version 3 of the ARM. It's still not functional yet, but I had to recently put it into the body of Gidget because I just needed that satisfaction of seeing it in its eventual place. One of the things that I discovered in doing that, version 3 has the same ARM segment dimensions as the previous 2 versions, but I raised the shoulder joint up just a little bit, and then discovered that it wouldn't clear the aluminum extrusion that I had here. So as you can see, I've solved that problem by putting a little notch up there. Another thing that I did was I was struggling with figuring out how the ARM was going to rotate or kind of pivot back and forth. And I originally put a little NEMA 11 motor here in the corner of the swivel plate, but it didn't offer enough force. So I had to figure out how to use a larger motor, and I was struggling to figure out how to fit it onto the swivel plate. And then it dawned on me that it didn't really need to be on the swivel plate. It could be on the fixed plate and then just move the swivel plate. So as you can see, it's hanging off the bottom there, and there's a belt that goes around, that's affixed on each end, goes around these idlers and then around a pulley there. So I'm pleased with how that worked out. The only challenge there was that this motor ran into a cross member at the back. That's been replaced with a 3D printed part with a little notch in it. For the sensors on the joints, the plan is to use magnetic absolute encoders. Originally, those were going to be sitting on the outside of the joints with the magnet tucked right into the shaft here. But I don't like robot arms that have things hanging off the outside. So what I'm doing now, let's see if you can see it. There's a small belt. There's a small belt right here that goes around a small pulley, and the magnet is in that small pulley, and the sensor board then hovers above that magnet. That's how those magnetic encoders work. So there's one here. There will be one here as well. The small belt's not in, but the sensor board is back here. And then I was trying to figure out how to accomplish that same thing for when the arm swivels. So I came up with, and again, I apologize if you can't see it well, but this white is a small pulley. there's a very small 3 millimeter wide belt that kind of hugs this black part right there, so that when this swivels back and forth, it rotates that white pulley and the magnet is on the other side. So I'm pleased with how all of that has worked out. I'm pleased that I was able to modify the frame to accommodate the length of the arm and the position of the motor on the back. And what I'm currently working on is designing a driver board for the stepper motors. And I'm designing my own driver board because it needs to have CAN. Gidget uses CAN for communication between the different systems. It needs to have CAN, and it needs to have an interface to connect with all those position sensors. And I haven't found a board that can deliver all that, so I'm working on designing my own board. I guess the last thing that I'm pleased about, I will say a lesson learned. Don't put your robot arm in the car and leave it in the car when it's over 100 degrees outside. Black PLA does not handle direct sunlight in that condition very well. So there were a number of parts that this part, for example, is supposed to be flat, but it's not flat anymore. This is one of the plates that's on the bottom of the arm. This is where the pulleys go that tension the belts, and that pressure from the belts, you can see where those are on the bottom because it forced those out. So there were a number of parts that I had to reprint after that. The other success that I had, or the other getting lucky that I was bumping up against the weight limit. And so I switched batteries. I originally designed Gidget to accommodate 3 12-volt sealed lead acid batteries right here. The drive motors are 24 volts, so I was going to use 2 of those batteries to drive the motors. The third would be for running all the electronics. But as you know, those sealed lead acid batteries are quite heavy. So I've switched over to smaller, and they have about the same amp hours. They're lithium ion batteries. And they're significantly smaller and significantly lighter. But then I had to figure out if I was going to have to rework that part of the robot where the batteries are. I hate doing things over, but it turned out that I was able to print this little tray. The tray can accommodate 2 of these batteries, and the length of the tray is the same as the sealed lead acid battery, and the width is about 1.5 of those sealed lead acid batteries. So 2 of these trays now are down in the bottom there, and I can accommodate 4 of these batteries if I choose. So that's my progress report.
Okay.
Can we
cool.
ask questions?
Yeah, go for it.
So first off, I just want to say that I think a CAN bus combined motor driver and sensor board could be really useful. I hope you'll share it. Are you going to make it like an Arduino Shield or something like that would be a popular format?
No, it's right now what I'm looking at is the SAM-D21.
Still, so you're going to make it fit that board?
Well, it'll
Or
have a
one of those
SAM-D21 on it.
Good. So it'll have the processor on board. That's even better. Excellent.
Well, I need so many I/O pins that I haven't been able to find a reasonably small, breakout board for
Sure.
that brings all the pins out. You can get nice small SAMD21 based boards, but they either use smaller versions of it because it comes in a 32, 48, and 64 pin versions. I think also a 100 pin version. But they'll either use a smaller version or maybe they might use the 48, but only bring half of the pins out. So,
Right. No, that'll be a great board. I'm looking forward to seeing that. I have a question about the base. I know you're a very competent person, and so the fact that your base rotation seems really dumb to me means that I don't understand some requirement of the design. The drive belt makes perfect sense. That's smart. I like that. The sensor makes perfect sense, but just because of the way the arm is mounted, that's a very limited amount of motion side to side, and I can see ways through like stacking the motors behind the arm and then turning the robot around and not having it, in other words, having the extension be where the robot sits so that it can turn more. So I'm just curious, I guess you don't need very much rotation for this application, or is there some reason in this application why the front of the robot has to be perfectly flat and vertical like that?
well, the reason that, yes, so the fact that the robot arm is inside of the robot when it's parked does limit the amount of swing that I can get in that rotating sled or that the arm's mounted on. I didn't think that I don't feel as though I need a lot of side to side, because to me that's the fine grain motion. The coarse grain motion will be just moving the robot. And even with just it's got 10 degrees side to side. Even with just 10 degrees side to side, that gives me that much motion at the end of the arm. So
Okay.
I feel like that's going to be sufficient for most purposes. And if it can't move far enough, it'll just have to move the robot.
So basically, you weren't worried about that very much, is the point.
Correct.
Cool.
New message is received from 48041.
Okay, thank you. Jim, you're up next.
Somebody gave me this robot a while back, like a couple years ago, and I'm trying to figure out what it is and where I can get information on it. If anybody knows it, has any ideas on that. It's got all these little boards that can attach to it with screws and things. I was just wondering if anybody might know where I could get information on it at.
I've seen that before. Put the bot up again. It looks familiar, but I'm not placing it.
No writing on it?
Yeah, can I see the?
There is someplace, but I've tried to get. It's called Micro Brick, and I went to a website, but it doesn't have anything about this on it.
Huh. I was gonna say it looks familiar as heck.
With
Can you
COVID
tell what
around,
process?
I was looking for things to play with when COVID was around here. So,
Yeah, I was gonna say, can you even tell what processor's on it?
not without a magnifying glass.
Yeah. Don't know on that one.
Okay, I just thought I'd ask.
Okay. So we still got a little bit of time left. Does anybody else have something they would like to share? If not, we can do like a 15-minute break.
I can share a quick thing on a silly little cardboard robot if
Go for it.
anybody wants to see it.
Yeah, go
Let
for
me
it.
share my screen here real quick. I think I may have shared this before at one of the meetings, but this is our little cardboard combat robot. And you can probably hear if I drive it. That's the servo. They're continuous rotation servos on there. We recently added a ping sensor, so you can see. Oh, I'm sorry, I don't have that connected. Okay, the word ping there has to do with the amount of time between responses from the robot. This the actual ping sensor or ultrasonic sensor is hooked up to this, and I didn't plug it in, but that is working. The thing that we've just recently added to this, so this basically just works as a remote control on your cell phone or your tablet or whatever. You connect to the robot's Wi-Fi, and then you go hit the main web page, and you get this, and then you can drive the robot around. But we wanted to be able to do a little bit more. So there's this little control panel that gives you trim on the servos, which is kind of handy. And there is an editor built in. Notice that the editor is being served from the robot. Again, I think I may have shared this already. I don't remember which groups I've shared it to and which I haven't. That index page that you're looking at there is actually this file right here. So if we want to, we can add stuff on here and save it back to the actual robot. And then if we do a refresh on this page, you'll see, I can update it. So it's a mobile web dev platform. But the part that I just added is actually these buttons down here, which is the animation buttons. And another little feature that's built in is, since we have the ability to have files and have an editor, and we can edit the files that are on the robot, we can make up these little animation sequences. And so it's a simple JSON file format where there's a single number, which is the number of milliseconds between entries. And then each entry consists of 3 numbers, which are the relative position or speed of the 3 possible motors that you can hook up. So basically that's the left wheel, the right wheel, and the weapons wheel, if you will. And again, these can be a continuous rotation servo, or they can be a standard servo, in which case that's the position of it as opposed to the speed. So this particular little thing puts the one motor at 100% forward, the other motor at 100% back, weapons motor off, and then it goes forward, forward, off, and then it goes reverse, forward, off. So it basically, when the robot is sitting there, executes more or less a turn, depending on how well you've calibrated that. And if you go back over here and hit this button, there's a slight delay, and then you'll hear the motors going through that sequence. Then of course, you can make these as long or as complicated as you want. So you can have a much faster sequence that goes through a more complicated set of motions, and you can fire that off again just by hitting the button here, and it will do that particular thing. The other thing that you can do is you can create a file called 0.json, and 0 is the kind of the auto exec file. So even if you're not connected, even if you're not controlling the robot through this thing, then the 0.json animation will automatically be running, will constantly be just going. And so the idea here is that this little platform, instead of being used as a mobile robot, can be used to animate some little diorama, or you could imagine a steampunk hat that has gears and stuff on it, or a pair of ears or whatever, and then people can just build these animations. And then the last thing about that is, I'm going through and trying to come up with little web pages that can be hosted on the device that then generate these functions. So this is a really simple one that just generates a circle. And if I go to, hold on, what was it, HTML? Circles.html. See? Computers want precision. There you go. Then basically it allows me to set the speed, the width, the height, and the number of cycles. And when I hit calc, it'll generate that animation file that we can then put on the robot. One of the things I'm hoping to do in the future is build up a version of a web page like this that has a bunch of slide controls in it, which would be, you can actually turn HTML slide controls 90 degrees so that they're vertical, and then each one of those would represent a time slice, and there would be a whole set of them going across, and that would be the position of that motor at that time slice, and there would be another set going across below that, and another set going across below that. And then that will allow you to make, you know, kind of animations by doing it visually, and there'll be a button that would make it run that animation, and then when you wanted to, you could save it off into a JSON file and run it. So that's what I've been working on for the fun of it.
James, can I make a suggestion?
Yes, please.
On your sequence, your JSON data, I would suggest that rather than have the first parameter be a speed, have each of the elements have
their own speed.
a duration.
Yeah. You know what? We actually did that, and that's what I actually had argued for. And what we found the first couple of times that we tried this out, this was with kids in junior high, and they found that format too confusing.
Oh.
So and I didn't want to abandon. I said, you know what? It takes a better user interface. We need to do a little bit more. But people were like, no, it's too complicated. So the other option that we had was to go to more of an object type format instead of an array format in JSON, where there would be named parameters.
Yes.
And I think the compromise that I had was that each entry would be an array, and then there would be the time number, and then a comma, and then a sub-array of 3 numbers. And that would then kind of, because what they had originally was they just had 4 numbers, and the first number was the time, and then the next 3 numbers are the motor positions. But I'm going to go back and say, hey, look, guys, I think that this will be easy enough if we just do the time delay, a comma, and then a sub-array with the 3 numbers. And so that sub-array will keep those motor positions separate, and it'll be clearer for people.
Gotcha.
So I'm gonna try to sell that. But yes, that's an excellent suggestion. I completely agree with it.
Yeah, okay. Well, and once you come up with a GUI for doing it, then it doesn't really matter anymore.
Exactly. It all goes away, and we're at a point where we're starting to have a GUI. So yeah.
Yeah, good for you.
Oh, it just dawned on me. I could make the first version of the GUI would be really simple to just be a table. And then I could name the columns of the table. Yeah. Thank you for bringing that up, because that made me think about it. Now I see that there might be even a simpler version than the sliders. Because honestly, the sliders are a pain to work with on the HTML side and JavaScript side. So thanks for that.
Okay, thanks, folks. Yeah, let's go for a 10-minute break, and then we will come back and we'll have Real Thunder do a presentation on FreeCAD. So I'm going to pause the recording while we do this, and I'll put up a timer. So we'll see you folks in about 10 minutes, and yeah, we'll go with the next step. Okay, folks, welcome back. That was our 10-minute break. What we got here? Okay, Jen, are you ready for the presentation?
Yep.
Okay, so next we have Real Thunder up with a talk on FreeCAD. So I'm just going to hand it off to you. Okay, all yours.
Hello, everyone. I'm honored to be given a chance to talk about FreeCAD here. And FreeCAD is a general purpose CAD software, not particularly tied to robotics, but as long as there is mechanical designs involved, FreeCAD will be a great tool for everyone. I'll first briefly introduce the history of FreeCAD development and also the origin of the FreeCAD Link branch that I started. Then I'll give a touring guide for the current version of FreeCAD. And finally, I'll highlight some noticeable enhancement in my branch. My name is Zheng Lei, literally translate as Real Thunder. I'm one of the FreeCAD core developer. Maybe some of you have heard of FreeCAD before. It is an open source general purpose parametric 3D CAD modeling software. It is licensed under LGPL, runs on all 3 major PC platforms. To all those mechanical engineer out there, the FreeCAD is similar to the commercial CAD software like CATIA or SolidWorks. FreeCAD is created by Jürgen Vigo around 2001, initially as a private project. The project is made public and open source in the next year. Unfortunately, his last work on FreeCAD for the assembly module was left unfinished in 2015. If he continued, maybe FreeCAD has already conquered the world. But then I might not be motivated to join the development. Who knows? The second core developer from the beginning is Warner Mayer. He is a former colleague of Jürgen and joined him as soon as the project went public. He is, to this day, still the most active developers of FreeCAD. Most of the core features need to go through him in order to get accepted in the official code base. The third core developer, Ulrich van Haber, joined around 2008. He is a professional architect. He is the de facto art director. You know, because an architect is supposed to be half engineer and half artist. He's quite good in programming for an architect. More and more people join later. As of now, there are more than 300 contributors for the FreeCAD code base. Visit the link here if you want to know more about the FreeCAD history. I made my first contribution in early 2017. Yes, I'm quite late for the party. I was a normal FreeCAD user before that. As a habit of a professional software programmer, I start to fix things and add functionalities that I wanted. I consider myself as an adventurer who always eager to try out new ideas. My current passion is to bring FreeCAD to the next level, at a level that can compete with some of the commercial CAD software. One thing special about my development though is that because of the fast pace of adding new features, the upstream has a hard time swallow it. Therefore, most of my new features I developed still only exists in my own branch, which I make release regularly for the public to try. I do intend to merge most of the new features I developed to the official FreeCAD. There are already quite a few of them submitted for review right now. I started using FreeCAD because I wanted to make a little gadget of mine. I was looking for the assembly functionality and quite disappointed to find out that there was no official assembly workbench in FreeCAD. There is an external add-on assembly workbench. It was quite nice for basic assembling purpose, but I soon hit its limit. After some struggle, I finally started to write my own. In order to have an efficient way of handling large number of potentially duplicated instances of components, I created a new core feature called Apps Link, or just simply Link, that works similar to the file symbolic link. This is quite a complex feature implementation-wise, so it didn't get merged to upstream immediately. To prove its worthiness of this feature, I forked out FreeCAD and added the link, and then created my Assembly 3 workbench as a demonstration of this feature. And this is how the name Link branch came about. I made my first release in 2018 and continue to publish regular releases with more and more new features. We'll get into it in more details later on. By the way, the link feature has since been merged and is available now in official FreeCAD latest release 0.19. FreeCAD makes heavy use of various open source libraries. Unlike many other CAD software, FreeCAD uses one file type to contain all types of objects, and it is possible to create links, yes, my link, to reference objects in other files for both data and visual. FreeCAD has a modular system design utilizing Python, which makes it possible to be used as a loadable library by other software. Almost all functionalities of FreeCAD is exposed to Python, and this is the reason for rich external add-ons that are created by other developers or even power users. Each module exposes its functionalities to the end user in the form of workbench. Here you can see how the user can switch between different workbenches when working in different domains. Next, I'll briefly introduce some built-in workbenches of FreeCAD. The part workbench can be considered as the core component for FreeCAD. Most other modules depend on the part module. It serves as a middle layer to provide CAD kernel functionality to other modules. The main modeling paradigm of the part workbench is the constructive solid geometry workflow, where complex shapes are formed by Boolean operations on other primitive shapes. That being said, the part workbench also supports using sketches and extrusions. Here's a short demo of creating a fusion, i.e. Union of a cube and a cylinder. and then cut it with a sphere. Perform a fillet operation on two of the edges. And because it's parametric modeling, you can easily go back and
I've got a pause on this side. Is anybody else still getting the video? Oh, there we go. You're back.
hello, yes.
Hello. Yep, we had a pause for a second, so the video feed cut out. So it's okay now, though.
Okay. Next is the Sketcher Workbench. It is another very important workbench that are developed, depended upon by many other modules. The Sketcher Workbench offers constraint-based 2D geometry sketching. Here's another short demo of creating a sketch. It uses the polyline tool for fast creating lines and arcs. Yeah, we then add a dimension constraint to fix one of the edge, and the equal constraint to fix the other. And finally, add a radius constraint to fix the whole sketch. And you can see that it turns to green when the sketches are fully constrained. And then you can go back to the part workbench and extrude it into a solid. Next is the part design workbench. The part design offers a modern workflow for creating solid with the concept called body. This is similar to what it's offering in most mainstream commercial CAD software. Here's a brief demo of the workflow. After creating a body, we fast forward to create a similar sketch as previous. After done, we extrude using a pad feature, and then continue to the next step of the modeling by creating a second sketch on the padded face. Here we also demo how to use external geometry, the magenta colored edge, for positioning and continue modeling. We then use a pocket feature to create a hole. And finally create fillets for the top edges. These are the basic steps you use to build up the model history and create a complex shape. You can easily go back and forth of the history by toggling the visibility. Next is the Tech Draw Workbench for creating technical drawings for 3D models. It has all the usual tools you can think of for creating drawings, like dimensions, section view, hatched areas, annotations, and so on. You can export your drawings to various output formats. Now we create a simple drawings for the models we just made in part design. The workflow is pretty intuitive. You can change different dimension style to suit your needs. It is also straightforward to create a section view and add a dimension on that. Finally, we finish with a customized isometric view of the whole model. The FAM Workbench offers a unified GUI interface for using various open source tools to perform finite element analysis. It supports NetGene and Gmesh for generating mesh from solid model and using various solvers to produce the result. I'm not sure how you robotics guys uses the finite element analysis. If for anyone that are interested in this, can just go through my slides. I'll skip this for now. Next is the Path Workbench. It is the FreeCAD's CAM module that generates G code for various CNC operations. It also has an amazing simulator to see the motion before actual machining. The Path Workbench is mostly written in Python, but with performance critical part written in C++, or utilizing other open source libraries such as OpenCamLab, Clipper, and LibArea. I was involved in its development when I first started contributing to FreeCAD, but changed my area later on. The Path module has since developed into a very wonderful feature-rich workbench. Now we are going to show a simple simulation. To make it more interesting, we create a thick shell based on our previous model. Here we show how easy it is to create a two paths to machine this piece. We use the zigzag offset pattern for combining pocketing and interface profiling operation. Now start up the simulation, and it's quite joyful to watch. Next is the Spreadsheet Workbench. The spreadsheet brings the meaning of parametric modeling to another level. It allows the user to easily create new parameters, calculate them using various expressions, and reference them inside the model. This quick demo shows the power of the parametric modeling. Here we create two parameters, namely the depth and width. The width is derived from the depth using an expression. We bind the parameter width to the dimension inside the first sketch. And then bind the depth to the padding length. And voila, we can control our model using the spreadsheet now.
Like, what are you doing?
Yeah, Harvard.
Then there's the Draft Workbench. This is the first workbench in FreeCAD that is purely written in Python by Yorick, one of the early core members of the development team. It is used to create simple 2D drawings without using constraints. One of the biggest users of Draft is the Ark Workbench, also created by Yorick, for providing the building information management workflow. I think there aren't many robotics people using the Ark Workbench here, so I'm going to skip on this also. But just showing some awesome pictures of the models that are available. There is a robot workbench built in FreeCAD. It has some basic functionality to simulate a 6-axis industrial robot. But unfortunately, this workbench has been inactive for quite some time and currently has no maintainer. I guess it is because there are many other powerful open source robot simulation software, and there isn't really any demand for a full functional robot workbench in FreeCAD from the community. As for now, there's still no official assembly workbench in FreeCAD, but there are a few popular ones exist as external add-on workbenches. They are all unique in their own ways. We can assume that the future official assembly workbench of FreeCAD will be a synergy of these three, inheriting their strengths in different aspects. Just in case you've forgotten that I am the author of the assembly tree. Speaking of external add-ons, this is another distinct feature of FreeCAD, showcasing its great extensibility. I'm showing only a tiny fraction as example here. We have the KiCad step up that can import a PCB file from KiCad. You can place your board and design an enclosure around it using FreeCAD. It can even modify the board shape and the component placement and export back to KiCad files. It can also build solid PCB models for the tracks and zooms and doing finite element analysis on it. And then there is the sheet metal workbench, allowing you to create various types of bands and later on unfold it for cutting. The new MB-Dyne FreeCAD workbench is currently under active development. It is a front-end interface for MB-Dyne, multi-physics simulation engine. Just look at the simulation result running inside FreeCAD. It's simulating the dynamics of the wheel while running on a bumpy road. There are many more great add-ons out there. Basically, anything you want, just do a search. If you can't find any, it's not that difficult to write one yourself, as many of the authors of these add-ons have done. Most of them are not professional programmers of any kind. Next, I'll talk about my link branch. Actually, I'm currently releasing 2 branches in parallel. The link stage 3 branch is the stable release. The name stage 3 is meant to celebrate the fact that my link feature finally got merged into upstream FreeCAD in its 3rd attempt. This branch is currently sort of frozen since the last merge with the official 0.19 release a few months ago. It still contains most of the new enhancement that I'll go through very soon. The link daily is the so-called daily branch release. Not that I actually make release daily, but I do develop and push commits on a daily basis. This branch is where I develop new features, mostly about the new 3D renderer that I'm currently focusing on. Here's a very brief summary of the enhancements done in my branch. The true extent of fixes and changes is huge. At the same time, I still try my best to keep in sync with upstream FreeCAD development and maintain backward compatibility as much as I can. Many first-time FreeCAD users have complained about FreeCAD's UI being old-fashioned. Feels like a 90s antique software. Well, here's the answer. My link branch maintains the same default UI configuration as the official release, but with a few settings changed here and there. You can turn this old-fashioned look and feel into this. It extends your workspace by showing all the UI panels overlaid to the 3D view. There is actually another external add-on that supports this type of UI overlaying upstream FreeCAD as well, but not as complete as my implementation here. The overlays support true transparency even for the mouse click. And there are various options for further customization, such as auto hide the panels, or maybe you prefer a darker theme like I do. To also notice the shadow casted by these casings. This is actually a 3D rendering enhancement. Although not using the new renderer I'm about to talk soon, the shadow display is available in the new draw style. Next is the enhancement of 3D selections. I have added the selection on top feature where the selected objects is displayed on top of the others and they become semi-transparent. You can easily select hidden edges of the on top objects. You can select the hidden faces as well using mouse wheel. Together with the pie menu, which is another UI enhancement, you can select higher level of geometries like wires, solid, and compound. My current focus is on developing a new renderer for better performance when rendering large-scale assemblies, and also more graphics effects like physics-based material, better shadow, ambient occlusion, reflection, etc. The renderer is already working to some extent, which offered improved performance. I've also just implemented two very useful graphics effects like last month, the cross-section filling and the shape outline drawing. There's a screencast of these two effects. You can customize the cross-section filling color. You can add hatch pattern with user-defined scale. And there's another new style called the hidden line draw style, which offers a similar rendering style as the tech draw workbench you just saw. There are options to override the background color, face color, transparency, and so on, and to show the shape outline. It can also be used in combination of cross-section fill. The difference between this and the tech draw is that here I'm showing this in real time, while the tech draw currently is facing difficulties in slow performance of extracting the hidden line information. Comparing to everything else, the greatest enhancement in the link branch is the solution to the infamous topological naming problem. For those who have never used the FreeCAD and are likely spoiled by what nowadays commercial CAD can do, here is a very brief demo of the problem. Traditionally, FreeCAD uses integer-based index to name the geometry elements like edge 1, face 2, etc. When the user creates a fillet like this, what FreeCAD remembers is the fillet is to be performed on edge 3 of the fusion object. But when the user modifies the models, like moving the cylinder a little bit higher, there is now an extra edge in the fusion. The index got mixed up, and the edge 3 is now referencing something unrelated. This is a fundamental problem that's been troubling FreeCAD users for decades, and apparently it's a very difficult problem to solve. The FreeCAD link branch implements a general solution to this problem by internally name each geometry elements using their modeling history. In other words, it names the edge 3 with something like an edge originally came from cube edge 2 and cut by cylinder face 1. So now when you move the cylinder, there is still an edge that fits the description. Well, actually, there are maybe more than one edges that fits the description. It is a design choice to whether choose just one or more. Regardless, the user won't face the disastrous outcome when an unrelated edge got fitted. Imagine this type of error happening in the middle of a very long history of a complex model. That's why the topological naming problem is the most criticized part of the FreeCAD among existing users. There are workarounds, but it requires disciplines. And obviously you can't ask that much for a new user. There's a great news that all of this soon to be a memory of the past. Here we show what more the enhanced topological naming can do. We created a body with a simple cube, making a thick shell out of it, and finally punch a hole. But what if we decide later on to punch the hole first and then make the shell? That'll result in a very different final shape. With the current FreeCAD, you have to manually correct each geometry referencing the affected features. And if this is in the early stage of the modeling, sometime we are forced to practically redo the whole model. Let's see how it performs now if we reorder the features. Once you reorder the features, it still shows some error. This is by design. It is a way for the software to bring attention to the end user for visual confirmation. When you double click the feature for editing, and the software will auto correct the invalid reference and show you the result. If everything looks fine, just hit OK. For those curious ones, here's some links to the details of the problem and the solution, and also the links to my branch so that you can download and give it a try. There are many applications of the new topological naming, one of which is the suppress feature in part design. You can now suppress any intermediate features without causing too much trouble of the following ones, and same goes if you decide to unsuppress it. Another application is the enhanced editing preview function in part design. The screencast here shows how you can just click the edge and immediately see a new fillet created in place. This targeted highlighting is only possible thanks to the new topological naming. There are still many rough edges in my branch, but it is a big step toward a more user-friendly and more capable CAD software, which I hope one day can stand toe-to-toe with the big players in the market. For more details about many more enhancements in my branch, you can search the YouTube for videos from a user named Office Sign Robotica, who is a friend of mine. We keep in close contact, and you can find many first-hand information of my latest development in his video. And that is the end of my talk, and thanks for all. And you can show your support to FreeCAD with the link here. Thanks.
Okay, thank you. We've got time for questions. So if anybody would like to ask some questions, just go ahead and open up your mic and go for it.
I'm curious about the releases, or rather the current stable version. So the current stable version seems to be 0.19.2, and my memory is that when I tried that, it was considerably behind. Like there hadn't been a new release in a long time. I may be wrong about that, but I'm just kind of curious if you can tell me, like, how do updates, like all the work that you've done on your branch, and then like the development versions, and then the actual stable release version, what's the like timeline or the process for those?
There might be some confusions here. The version, the 0.19 version you're talking about is the official FreeCAD release. Commonly, the official FreeCAD release a stable version every year, but it constantly maybe a weekly release of its development version. Now it's the 0.20. They do a weekly snapshot of their current code base, and I follow their development quite closely. The 0.19 is released about 2 months ago.
Okay.
Yeah. My version is actually not released on. I have shown a link in previous pages of where to download my release. It's in parallel with the official release. Because my rate of adding features actually faster than the upstream, and I actually rely on the user. Of course, I'll test myself, but I'm just one guy. I rely on the users for testing and reporting the problems. Then I'll fix and make another release.
That's really what I was trying to ask is, do you have a sense of the timeline? You know, how long will it be before the work that you've done here, which looks very exciting, you know, how long
you are asking when my features can be accepted upstream, right?
Yeah, and how can we make that happen faster, and what's holding that up, I guess, is the question.
I guess it's depending on how mature those features are, and how many users have already been tested with my release. That's one factor, of course. The most important factor is how the current maintainer of the project, Warner Mayer, I talked about the second core developer of FreeCAD, how he accept those changes, because there aren't many C++ guys there that can review my new features. That's that's why that's the reason of those delay. For the next version, next major release, 0.20, I think the most important stuff is the topological naming I talked about. And also the UI, the overlay UI is already happening in the background. The topological naming is also happening. Exactly how long will it take? I'm not sure actually.
Is there anything that we can do to help make that happen faster?
For the end users, just test the, if you want for example, the topological naming. Currently, I split into 3 set of patches. The first patch is already in the queue, but that one is mostly for the developer to test. If you want to test the whole features, just try and download my release and try it out. Report any problems you've encountered. Yeah.
Okay.
Okay, go for it. Other questions?
I was wondering if you could paste the links from some of your slides in, like I didn't quite catch the spelling of the name of your friend, of Fishy or something.
You can find my slides, the slide link in the chat. It
Oh, okay,
will
thanks.
have the first, I think I'm the first one who posted the link.
I see YouTube links, but I don't see slides.
No, the first one, the very first one. Hey, where's the chat window?
The very first thing I see in the chat room is "Thank you, Real Thunder, for speaking today."
Okay.
Oh, yeah,
You've just
depending
missed
on
it.
when people join this meeting, they
Okay,
don't see the historical chat entries. You have to repost it.
Okay.
Thank you.
Okay, and I'll snapshot the chat as well, so we've got that captured with the video. Okay, are there any more questions?
Yeah, so RJK has been asking in the chat several times, actually, if there's a way to incorporate ROS2 with FreeCAD.
Is there any demand for this? I'm not sure.
Well, I guess that would be related to the integration of the robot simulator. I take it you're not involved in that.
No, not right now. No.
And nobody's involved in that.
Yes, I think there's little demand because you see there's the robot workbench is quite old already, and seems that nobody's using it.
Okay, anyone else?
Well, firstly, thank you so much for doing this, and I'm very excited about it. I downloaded your branch, I guess, in 2018 for the assembly features, and I'm quite a casual user. I just now have been compiling your latest branch. I picked link stage 3. I wasn't quite sure. I noticed something today, which I noticed when I compiled it in 2018, which is that at least for me, when I build it, it dies, and I have to restart the make from midway to get it to compile all the way through. Do you have any idea why that is?
You're on Linux, right?
Yeah.
Yeah. Sometimes the Linux parallel build, you are using parallel building.
Correct, J3.
Yeah, that's time for some reason. I'm not sure exactly why, but parallel build on Linux sometimes got problems like race condition or whatever. You have to restart it. Just restart, it will continue from where it stops.
Great. It gives me confidence that I'm not doing anything terribly wrong. So thank you.
Okay.
But I love what you're doing.
Thank you.
Okay, anyone else? Okay. Sounds like we've wrapped this one up. Thank you very much for the presentation. That was awesome. It's, FreeCAD's something I've been looking at as well for a while. I'm going to go ahead and stop the recording at this point. Let's get that done.